I'm Anil from Babaji Vidyashram School, Chennai, and I'm 11th grader.
And I'm going to explain my science project to you. So what we have here is a science project which I've made myself. Here I have 5 different segments in the project, which is smart gardening, house control, remembering Rover, emergency protocol, and a laptop battery, Powerbank. So what I have here is my first project, which is smart gardening. Here I use 5 different parameters or 6 different parameters as I've expanded my project. So I have 6 different parameters which will be used for manipulating the growth of a plant. Here we use temperature, humidity, soil moisture, light intensity, rain sensing and gas sensing for understanding how does the plant grow, what conditions it requires for growing. We use moisture sensor to find out what moisture content is present in the soil, as plants require good water content for the roots to expand and nutrients to be taken through the water and for the plant to grow. Then we have temperature and humidity, at which temperature the plant grows and at which humidity the plant grows. It is very important, it is vital for the growth of a plant. Then similarly we use light intensity. Light intensity is another very important factor. Without the presence of photons, plants cannot grow. They need light, water and air. So without light they cannot grow. So we use the light intensity sensor, we have used a light dependent resistor, which is increases the resistance based on the intensity of light. So as the light intensity decreases or increases, it finds how much light intensity is present in the surrounding where the plant is growing, and depending upon that it turns on and off lights. Similarly, we can also sense for rain, as rain droplets can be sensed by my raindrop sensing module. We can use that to sense rain before the rain even starts. Since we have different stages of rain, rain just doesn't fall like that. Precipitation doesn't take place just like that. We need water droplets where there is drizzling taking place, and then we have showers. So we can sense when it is drizzling and we can just take protective measures for the growth of a plant. Then we also have gas sensing. Gas sensing is a very important feature, as gas immediately reacts with how the plant grows. It can give harmful chemicals, let it be poisonous, where we have weeds coming out. So all this can be manipulated by just maintaining the levels of gas. So our gas sensor checks for benzene, butane, propane, all these carbon compounds which are present in natural bases. So these react with the plant and manipulate the growth of the plant. So this also can be taken care by my project which I've created, the smart garden. So let's show you a demo right now.
So as you now see the program, you can find out all the parameters that I've told you about here. So welcome to Garduinoo, the autonomous caretaker of the plant. Today we are here going to measure temperature, humidity, soil moisture, light intensity, rain sensing, gas sensing. So the temperature is 28 degrees Celsius. So it takes the protective measure of not watering the soil. Humidity is 95, so there's high chances of rain, which you can find out. Moisture content is minus 81%, and thus you would have heard the relay click. That shows that the motor is watering the soil. Light intensity is 991, as we are in a completely lit room. Rain sensing value, the raindrops are not to be felt on the rain sensing pad, so there's no raindrops. And the gas value is perfectly normal in my room, and we have no objects at any distance. So this is how the program runs, and so we get many different parameters as inputs and outputs. This is how the program automatically takes care of the growth of the plant, and it ensures that the plant gets all the necessary values and all the necessary parameters where it needs to qualify, so that it can have safe growth and it can completely grow.
So here we got our moisture sensor. So since it was in water, it gives a high reading of moisture values. So if we immediately remove the moisture sensor from water, there's no more moisture on it. So when it goes for the next iteration, it should possibly take the protective measure to give out water. And there you go, it's pumping water. It pumps water for a duration of 10 seconds, after which it finishes its iteration. So it checks for the next iteration. So in similar manner, we have different other moisture other sensors working here. This is the temperature and humidity sensor, which tells us what is the temperature and what is the humidity in which the plant is growing. This is the gas sensor, which checks for the gas. And then we have the rain sensor, which checks for the rain. So this checks whether raindrops are felt or not felt. This is our high powered relay module, which gives out the water pump its signal to pump water out. And we also have a barometer and atmospheric pressure sensor. So this way atmospheric pressure and barometric pressure is maintained. So the second project which I'm going to speak to you is about IoT, where we are using IoT to control the devices in our house. Let it be smart devices or non-smart devices. Now you may think how. These analog devices are controlled by electricity, and we can control the flow of electricity by which they become indirectly smart. So what we have done here is I have a simulation of a house where we have lights, fans, and these devices are low powered devices. But the same manner we can use Arduino to send low voltage signals, and that can be sent to a relay module from which it can connect to high voltage signals, and these relays can be used as magnetic switches. So you will not have any more switches in your house. These switches are electrical switches which work on the basis of magnetism. So these magnetic switches turn on and turn off high voltage devices as it gets signal from our Arduino. So what we have done here is we aim for saving electricity by using this process, where we use small microcontrollers which can control non-smart devices and make them smart in turn. So by using this project, you can just not make smart devices connect, but you can make non-smart devices connect, and you can make non-smart devices or analog devices such as fans, lights, control from anywhere in the world. For now, I have Bluetooth transmission where we have serial interfacing, but in the future we can use Wi-Fi serial transmission. Wi-Fi serial transmission, what it aims on is we can have our own Wi-Fi module. This Wi-Fi module will produce its own internet network. So this network, internet is a network of networks, right? So now you can see as I've connected, this module is called as the HC05, as you would have seen in the video. So from this HC05 we are transmitting and receiving information. So here we can turn on and off lights in the house which we have made. So There you turn on one segment of lights in the house, another one there, off and off. Way we just do not need to have limited sensors in our house, but we can use rain sensors and gas sensors. Let it be like we have in our capital city, Delhi. There's a lot of pollution taking place. Like in your house, if you have like by mistake left the gas on, so the gas sensor can sense for all these inflammable, highly inflammable gases, compressed natural gas and butane. So all this can be sensed, and then we can turn off the gas immediately by using a mechanism. Similarly, we can use relays to control the phases of current in a house. We can block the phases of current based on how much, based on the signals we send again from Arduino. This all can be controlled by the application which we build on our phone. So relays and Arduino together are a powerful technology which we can use to bend the electricity flow and technology to our needs in the house. So this application will have the access to the Wi-Fi serial module. The Wi-Fi serial module will then instruct whatever we are doing. Like the app will have to turn on and off lights, turn on and off fans, turn on and off geyser and high voltage electricity devices, high voltage electrical appliances. So all these appliances can be controlled by using this technology, and we also have built in a security measure. This is the ultrasonic sensor which I have here. This ultrasonic sensor is like the eyes of the house. Most of the malls have security measures where they use CCTV cameras. CCTV cameras work, but they work only when light is present. Even some cameras work when light is not present, but that camera costs a lot. Whereas we can use CCTV cameras as well as side by side use ultrasonic sensing, because ultrasonic sensing works on the basis of sound waves. By this, we can be able to use ultrasonic sensing even during the night time. So when you have like are out of station and you notice that there is some movement inside your house, this can be sensed at any condition. Let it be when it is like during the daytime or during the night time. So this way we can find out what is happening in your house, let it be at any time of the day. So ultrasonic sensing is a very powerful tool which we are using for a security measure. Which is emergency protocol. What happens here is we have light dependent resistors. So the light dependent resistors which are present over here, those light dependent resistors measure what is the light intensity present in a room. Based on the light intensity present in the room, we can like turn on and turn off lights when there's an emergency situation. So now I'll give you a demo of it. Since we have a lot of light present in the room, the LED is turned off. Now as we turn off the light intensity in the room reduces. So as it goes for iterations, it should turn on the light as it is sensing all the different values. Any moment now. So it turns on the LED, and similarly when we go and turn on the light, it immediately turns off the LED. Now since we have turned on the light, it should turn off the LED on its own as the light intensity is good enough. It's turned off on its own. So this way it senses for light, let it be during the day or during the night. So this can be used for a variety of applications. Where people can be walking in the night. So when there's motion seen, that motion can just trigger the LED to turn on, and that way we can see the staircase during the night. It can be also used in emergency protocols which take place during malls, in our house when there's an emergency situation, or when light turns off we can use emergency battery pack which I've made. So those emergency battery packs can turn on the lights immediately for safety measures. So this way we can use this project. Here we have the laptop battery charger or the laptop battery power bank. So what I have done here is I have taken a 14-year-old laptop which I have had since for a long time. So what I have done is most of the laptops have a laptop battery pack module. This module, what it does is it manipulates how the battery needs to charge. In a typical laptop battery pack, you have almost 6 batteries, highly rechargeable, and they produce a lot of current and voltage out of them. So what I have done is I had opened the laptop battery pack and then single-handedly removed each battery and found out how much voltage was present in each of those batteries. There were 3 volts present in most of the batteries, whereas one of the battery was worn off completely. So this shows that the battery manipulating module did its job by phasing how much of the voltage needs to be given to each of the battery. What I have done is I have made my own model of a power bank. So I have connected all the batteries here, all the positives and all the negative sides of the battery in a single line to produce almost a voltage of 15 to 20 volts. This is used to power my own super powered water pump. So we have also used battery powering modules. So power bank module is here. So this power bank module manipulates how much of the electricity needs to be given. There is a microcontroller and a transistor here which opens the gates. So we can use a USB charging port to recharge the battery when we want, and use it to control digital devices, connect it to digital devices, or power up any device. Like this is an analog device which I have used here. So this is the laptop power bank which I have made, and this is completely rechargeable and very much useful. So this is my last project, remembering Rover, the mapping bot. So what I have here is a Lego driving base which I have made. So what happens here is this robot is programmed to remember a location. Let it be a small location or a big location. We can use it in Boeing factories. Boeing factories are huge airplane factories. So what happens is they do not remember where they need to go to. Like all the workers there, they do not remember. For working for 20 years, they say that the factory by itself is a small city, so they cannot remember where to go, what time to go, how to go. So we can use these type of rovers which will remember the area much better, and they can be used to guide people. We can also bring in facial recognition, and we can bring voice commands. So this way it will be able to make it more user friendly. So what I have here is a program which remembers small areas. So this button is programmed, so when I press the button, it goes to a specific location and comes back. And it also has obstacle avoid mode where it uses the ultrasonic sensor. This is a very handy feature, as there will be a lot of obstacles and objects coming in its way when it is traversing. So we can use this also as a So this way we have an obstacle avoiding. So all this takes place in this project. And in this way, we can use robots to assist humans, let it be in any location under proper programming.
That whoever is watching this video and all the ideas which come out of students like me, these ideas are taken and scrutinized by all the industries so that life can be made better on our planet, and these ideas can be used because all these ideas take time to come into, and don't leave the video by just having a look at it. But thank you for watching. Hope that you had a lot of fun watching this video.